Good evening, my name is Wait Benjamin. I'm a full stack developer and I'm transitioning from web development to web development. So this is I and my teammates worked on a project called the auction app for the Rich Hackathon. So basically this auction app just works like every normal auction in the real world would work like. So basically we have the auctioneer and the bidder. The auctioneer, which is the creator of the auction, and the bidder that bids to become the new owner of the auction item. So basically this is the back end of our code. This is the back end of our code, which is index.rsh. So basically I'll give you a rundown of the code, then we can proceed. So this line 1 talks about the rich version, which is version 0.1. Line 3 to 6 talks about the auction prop, which are the starting bid and the timeout. The starting bid is as the name goes, the starting bid for our auction, and the timeout is the duration that the auction will last. So from line 8 to 10 we have the bidder prop. Bidder prop is an object that has a function, getBid function, which is a function by which the bidder can interact with the back end and give our smart contract its bid, the bid, so that we can store it on the blockchain. So the next few lines, line 12 to line 17, defines the owner interface objects, which are basically on line 13 we see the show owner function, which basically displays the owner of the auction item that's going to be auctioned. So basically in the show owner function, it takes three arguments. The first argument is the name of the item to be auctioned. The next argument is the address of the owner, which is like an identification of the owner of the auction item, and then the third argument is the item itself that wants to be auctioned. So basically what should be auctioned will most times be an image, which will basically convert to an array buffer and send it to the back end so it can be stored on the blockchain. So the next line we talk about the auction prop. This is basically an interface by which the creator can interact with the back end to show by which the owner can interact with the back end to show the auction props, which are like the starting bid and the timeout. Then the get auction props is the function where the back end interacts with the front end to get the auction props from the front end. Then this is basically a spread operator that just imports all the bidder props that we have here into this object. So that is just that. So from line 19 to 23 we have the creator interface. So it first imports all that is in the owner interface into this object, and then it has two more key value pairs. The first one is getID, which is basically a function that gets the ID of the owner. Then the next one is it's a function that actually gets the auction item, which is the item that is going to be auctioned on. So that is it. Then in line 25 we basically initialize an empty auction. So an auction where the starting bid is 0 and timeout is 0. So on the next line we have the main part of our rich application, which is initialized as main. So basically this is where everything about our rich application, the steps and the application initialization is going to be kept. So the first few lines is what we call the application initialization. So in this from line 29 to 31 we have initialize the participants of our application. Basically the way Rich works is that Rich actually has different, in the Rich app it has different phases. We have the application initialization, and we then have the steps of the app. So first we're going to initialize the app with the needed components, and then now jump into the steps of the application. So in our initialization we basically create our participants, which is our participants. Our first participant is the creator of the auction, and our second participant is the owner of the auction item. So basically this first this first participant is basically like the auctioneer. Let me initialize it to be the auctioneer. Is the auctioneer of our is the auctioneer of the auction, and then the participant class are just the bidders of our auction. So basically, this is the participant function basically takes another argument, which is just an object called the interact interface. So this creator interface was initialized at line 19 to 23, showing this interact interface is the way the back end, which is the which application interacts with our front end, which is the React application. So that is just basically it. And also the participant class is just for a group of participants. So this our group of participants called the bidders have their own interface called owner interface, which we have initialized here at line 12 to 17. These are the functions and variables that the front end and back end can use to interact with. So the next on line 31 we have the init function, which basically separates the application initialization from the steps of the application. So basically that's how it works. You have to separate the application initialization from the steps of the application. So in the steps of the application, there is just from line 33 downwards to line 90. So basically we have what we call local steps and consensus steps in a rich application. So a local step is a step that's only run on our local machine, while a consensus step is a step that is run on the blockchain. So this creator dot only is a local step, and so in this local step this local step is only indulged by it's going to be run only by the creator. So in both participants of exchange with the creator and the owner, only the creator can run this step. So this is a local step that only the creator can work with. So first, so what we do here is that on line 34 is that we kind of get the identification of the owner, which is like the ID of the owner's address, something like that. So when we get the ID, the ID is we get the name of the auction, kind of the name of the auction item from here. So basically we interact with our front end to get the name of the ID of the auction item, or the name of the auction item. So on line 35, okay, we get the auction item by using the interact interface object. So there's also this function called the classifier. This function basically decrypts the information that is coming from front end to the back end, or from the back end to the front end. Basically in read the action between the front end and back end is usually encrypted. So this is the classifier function, helps to decrypt that information. So the next step we have on line 37 is a consensus step. So this consensus step is a publish function, which is publishing the ID of the owner and the auction item to the blockchain. So basically the ID is like the name of the auction item, and the auction item is just the auction item, maybe an image or a JSON file or anything. So basically, as I told you, the image is going to be converted to an array buffer, or a data URL that can be passed as a string and sent to the blockchain. So on the next line we run an invariant while loop. Basically this kind of while loop in which is what we call an invariant while loop. So this is a loop that kind of runs on the blockchain as based on conditions that are set by it. So the first condition is that the owner will be equal to the creator. So for this loop to run, the owner of the auction item must be the creator of the auction item. So in this sort of application, this is like when we start the auction. So basically the condition for the auction to start is that the owner will be the creator. So basically then we also run an invariant, which is checking that after our application runs, or after the loop is over, that the balance of the contract will be equal to 0. Basically, in which basically it is a rule that at the end of the reaction, at the end of the application, that the balance of the contract must always remain 0. So that is how which operates. So in the next line, while these conditions are true, while these conditions on line 39 and 40 are true, this everything here is going to keep running until this any of this is going to be negated. So basically we now have a commit. The commit function basically separates the local step from a consensus step basically. So here we have the owner, we have a local step basically, because all these are consensus. This is a consensus step. The publish function is a consensus step, like .publish, .pay, .timeout, .fork, and rest of them. So in the local step basically, this next line we have a local step that is only done by is going to be only done by the owner. So here we have different things that are done in this function. Basically, the first thing here is that the owner interacts with the front end to basically asks the front end to basically send to the front end the owner of the auction. So the owner, which is the creator of the auction, we pass in the ID, which is the ID that have been published to the blockchain. The ID is like the name of the auction item. Then the owner that we pass here basically is the address of the owner, which is good. Then the auction item is the auction item that has been passed into the blockchain by the creator. So that's how we interact. Then we also make sure here this is a constant owner. This owner kind of this owner basically is a boolean value that asserts that this contract, that this is equal to owner, meaning that the person running this code running this step of the application is the owner. So the next part of application is basically we are running a ternary operator. Ternary operation, basically the ternary operation, like an if and else statement. We are checking if the person is the owner. If the person running the step is the owner, basically we get the auction props, which are the starting bid and the timeout. Else, if the person is not the owner, then we would return an empty auction that we have already initialized above. So this is the empty auction we initialized above. So basically we deconstructed the result of what we're going to get to bring out two separate variables, starting bid and timeout. So then in the next line we basically interact with the front end and basically send to the front end the starting bid and the timeout of our application of the auction basically. So in the next line we publish the starting bid, we publish the timeout to the blockchain, and we run more consensus step, like checking when the owner changes hand and a timeout equals to false. So this when owner is always going to be checking that as long as the owner is still, as long as this is still the owner of the auction item, there is not going to be a timeout basically. So it just checks every time the loop runs whether owner is equal to true. So basically then in the next line of our code we basically make a deadline from a timeout value that was sent to us by the front end basically. So making a deadline, we use the make a deadline function, and we deconstruct the array that it gives to us to time remaining and keep going. So this time remaining always just returns the time remaining in the auction, and the keep going just is a boolean value that checks whether whether the time remaining is still enough to keep going or to keep going with the auction. So that is what this does. Then in the next couple of lines we just talk about, it just discusses, it just depicts how the bid process occurs. So basically what happens there is basically bidders have to always bid continuously until there's a timeout, and basically the highest bidder wins. So basically what we're looking at here is so basically what we are this is a race condition, because both all the bidders which are participants for application are going to be publishing their bids in a race against time to be the highest bidder. So when you want to kind of run a race condition, though there's a race function in which, but to use a parallel reduce to keep to loop to use a loop in a race condition. So this parallel reduce function is kind of a looping in a race condition. So the race keeps going on and on and on until there's a timeout. So that's what the parallel reduce function kind of does. It's just a loop and race condition kind of. So basically in the parallel reduce, it's just like a while loop kind of. It has an invariant and a while condition, and then has cases. So these cases are similar to the cases we find in dot fork function. So but it's kind of like it. So basically the first we have these values, the winner, first bid, and current price. So basically this parallel reduce function initializes each of these values to the values above. So basically the winner our of the auction is going to be the owner, and first bid is going to be true, and the starting bid is going to be the current price. So the current price is going to be the starting bid. So then the invariance always checks that the balance is equal to 0 if it's the first bid, and if it's not the first bid, the balance can be equal to the current price of our auction. So basically in the next line we basically run a while loop which uses the keep going function from make deadline function that just checks whether there is still time remaining in the auction, and it keeps going as long as time remains in our auction. So then this is the case of our auction that just basically returns the bid of the bidder in a long process basically. So what all this does is just to basically return the bid of the bidder continuously. So basically this case is usually run until everything here in this parallel reduce function is run until there is a final winner basically. So basically in this bid there is basically return the bid of the bidder. So then basically in this last line we check the time remaining in the time dictated by the creator of the auction. So we check how much time is remaining in the auction, so that if the time finishes we can call for a timeout and the winner becomes the highest bidder basically. So kind of in this line 75, basically after every round of this bid you basically return the funds to the previous highest bidder. So maybe you placed a bid on the auction maybe for 100 algo, and someone else is coming in to bid for at a higher price. Basically we return your money back, and basically you bid again if you still want to bid. So instead of your money being locked in our smart contract, you basically return the money back to you, and you can bid again and again until you have the highest bidder. So some of the things that are done here are just to get this here with the classified information of getting the bid of the bidder from the front end basically. So this may be function kind of is just kind of a type in which that makes sure that the value returned is either some value or a non-value. So some value is just like a value that has a number actually, and the non-value is just a value that have nothing basically. So this is what it does. Then after all this, after they have been the higher, after we have gotten the highest bidder, basically we transfer the current price, which is the current price of our auction item, to the creator of the auction or to the owner of the auction basically, and the owner of the auction becomes the winner of the auction basically, because the owner basically is the winner. If you win the auction, you own the basically own everything in the auction basically. So you own the auction item and everything, so the rights are sent to you. So basically the continue here is just to break us out of the while loop. After the while loop is over, we leave the while loop. Then here we commit, and then we exit from our application. This is basically the rich back end of our application. I can't actually go into details about the front end, which is React, because the purpose of a hackathon is not for React, basically it's for Reach. So I'm sorry if I can't actually run the web version of my code. So this is the web version which was built with React. It also uses Redux and React Router and the rest of them for optimization kind of. Redux to have a single source of truth, and React routing for routing between different components and all that. So this is the app.js, the index.js and all that. So this is my application. This is my application, the auction app, and it's a really nice application. And I'd like to thank Candice, Safini and Dick for having a wonderful opportunity developing for Reach. And if I have unlimited time and resources, I still would keep developing for Reach. So I think the video has become too long, and I'm coming to the end of the video. So basically, thank you. God bless you.